I'm Bhushan Wagh. I'll be talking about the build your own React renderer. Just about an introduction. I'm software engineer and I'll be working. I'm working since like a last couple of years. I mostly work with the graphics rendering part of the on the web. And the UI part. So I'm a front end developer with the 3D rendering or graphics program. So most of my career went through like two parts of the application. One is like a DOM, working with a DOM, and the other is like working with outside of the DOM, where like I work with a WebGL APIs, which are like a browser's API to render graphics on the canvas. So I think during working through those things, I think I came across something like a problem where React is a really great tool to build the UI, how it really enhances the developer experience, how it really powers the creation or building the UI very fast, which is really great. But then again, when you go back to the WebGL APIs or anything that is outside of the DOM, and then you have to integrate with the React, or you want to something like a React. When you see something like a things happening in React where you can create the things very declaratively, you miss that, right? So you will. So I think so. The idea comes from there. So it's not a new idea. It's been there around for like a 4 or 5 years right now. So to understand like so we're going to talk about like a build on React renderer. For that we'll talk as so divided this talk into like a 3 parts. It is simple. We'll understand what is a React renderer, and then we'll understand why we need React renderer, and then we'll just build it. Okay. Building will be like a very small example. We'll go to that. So first, what is a React renderer, right? So to understand what is a React renderer, you'll have to understand what is a React. So so initially, as I started, we have all went through the interview questions where like we asked like what is a React, and then we answer it like something around like it is a declarative it is the library which lets you declaratively create the UI, but it is more like a definition for a React DOM itself, but not for the React. When you say React is a library that lets you declaratively create the tree structure of the stateful elements and components with some effects, and it is expressed in JSX. So what do I mean by that? And React is not a web framework. Okay. So basically, so this is the diagram I came up with. So React doesn't really understand what is the DOM, how to create a DOM or anything around the DOM. It just knows like it has to create the tree structure, and it has to optimizely understand where to update the tree structure, when to update the tree structure. So it just creates, deletes, and updates the tree structure, but it doesn't understand what the tree structure is, about what tree structure is, what each node is. Each node can have a state. Each node can like some prop, which is data coming from the parent. It knows that, but it doesn't know what it has to return, right? So how does it create the DOM? So if you go to the index.jsx file in your React project, or main.jsx if you're using white, you'll see you import two packages separately. One is the React, and another is the React DOM. So React DOM is basically a React renderer. So you use the React DOM as a React renderer to create the UI, and then you use React to create the tree structure. So basically how the code architected in the meta. So basically in your project you'll have something like a React, right? And then it will have a React DOM. So React DOM is specifically is made up of two things. It has a reconciler, and then it has a DOM hosting configs. Okay. So what it does is like so basically React renderer is just a plugin. You'll have some configs, like it you'll just basically give it a prompt like how do you create something. So for the DOM, you'll if you get something some element, how you would create that. So you'll do something like a document.create element, or if you want to append the child or add the child, then you'll do like a parent.append child and then add the child. Same for the remove, you'll do something like a parent.remove child or child, right? So that's what the reconciler is doing here. So I'll just try to showcase. Okay, I'll have to. So every time you write a JSX element in the your React thing, and it will give some, let's say, styles. So when you write something like this in a React, it is not a something you are writing HTML, right? It is a JSX. It will be get transpiled into something called React.createElement API. So it will look something like React. Uh, it will give the div as a type because you created the div, and then it will just give you the props which are like styles, and it will be the object of color, right? So this is like a, even going before going to the browser, even given going before going to the browser, or Babel or any transpile tool will generate this code, this API out of your JSX, right? So here React doesn't understand what is the div. It just knows that you have used some JSX element with a div. It doesn't understand what it is. It is just a prop for it. It is just an object for it. It is just that. It doesn't understand anything that. All it all it's going to do is like when you create it, it's going to run some methods like someone created the node, or someone appended node to the another node, or someone has like a deleted the node. So it will just give you an it will just sort of like a trigger those events, and on those events what do you want to do, that will be done in the React DOM. So React will do this, and the React DOM uh, will tell like what it has to do with this code, right? So when the it goes to the React DOM, it will be like okay, cool. So I got the div. So what I have to do is like create a div. So it will just create a div, and it will be like document dot create element, and it will create div, and it will append those just styles, and let's say it will just do red. So this is like a, this will be the whole process. You give the JSX before going to the browser. It will go to the React create element API, and then from the create element will React will trigger some event. This some event has happened, or some method has to happen. Something has to create, and then React DOM will give this like a what it has to happen like on the creation, how it has to create, right? That's it. So what React team has done, and there is another called React Native. So if you see, everything is the same in here. So in the React DOM, you use something like a div h1, h2, p, but in React Native, everything will be same. All you will be doing is, let's say you will be creating view or text. Same process will happen. In the end, it's just a React Native which will explain like what it has to do with a view, or what it has to do with a text, how it has to create the mobile application based view or text, right? So what React has done is like, oh, this so React is shared, so it is a different package. A reconciler is a same, so it is a shared package. So they have like a created different package for it, and you the only difference is like a host configs. So you can define this host configs. So what React has done is like it has like a published this reconciler or a React reconciler as an open source package, so you can use it to create your own renderer there. So React DOM and React Native are the officially created by the React, but you can go to the some community based renders that are created. One of the most famous is the React 3 Fiber. It is a renderer for the 3JS. It lets you create like a canvas based 3JS elements using the React, correct? And we can use the same things in our to we can create our own configs, and we can create our own React renderer, right? Then question arises like, why you want to create a React renderer, right? I think personally, while working with the React and then Imperative API, one thing I found is like uh, most of the things we talk about React is like it is very performant. It is good for the performance. It updates really well. It knows when to update and why to update and where to update, right? So you don't have to worry about that. But I think more than that, React is helps us with something like a JSX. I know JSX is not very related to the React. It is a completely different thing, but it gives the JSX, right? So if you want to create some UI in a web, you'll say something like a T structure using the JSX. And if you look at this, if you want to do the same thing in the imperative coding, you can see like we'll have to do like a create element, and then you'll have to do like a append to the child and append to the body, and then you will have to append the child to the another element. And you can see like the when you have to like something like a T structure UI element, it makes more sense to read in the JSX format, because like literally it is like showing you the what is the layout, instead of the imperative API, where you are just writing the lines of the code and you don't know what's where is connecting, correct? So this is one of the reason. And second is the reactivity, which comes really big. I think one of the simplest example we all have seen, like a counter, where you just press the button. On pressing the button, you change the update. On update, as the state updates, wherever you are using that set, that element will get updated, right? Very simple. But if you have to do the same in the imperative API using vanilla JS, all you have to do, you'll have to do like first you'll have to do all those creation. So we'll have to create a static UI first, and then you'll create some state, and then every time you attach the event listener, and you on the triggering that event listener, you will do something like a count plus plus. Apart from that, changing the state, you will also have to manually change the UI component. So now you have to be worry about like if you're syncing your UI and state together, even though you are changing the state, uh, you also have to worry about the UI, which makes no sense. Of course, you can in a big project, you will probably go for the pub-sub mechanism, where you will have like some custom event. On that event, you will update some state, but then again, you will have to worry about like if I have put the right methods. If you haven't, like you'll just it won't show up on the screen, which makes no sense, right? Third is like I think third is the biggest one, is like ecosystem. React is really big. The only reason I think React is more and more getting even though the new frameworks or new libraries are coming up, why they are not able to take the place of the React is because of the ecosystem. Maybe Solid is doing much better at the doing what React is doing, which is like just updating the things, or like a React is there where you can get a very these signals and very fine grained control over the states, right? You can do that with the Preact, but you will hardly see anyone using the Preact or something like that, or Solid. So the reason is ecosystem. You don't want to reinvent the wheel. You don't want to create something from the scratch and again, because React, you're using React just to save the time, right? So it makes no sense to go to some new framework and then bring it that create something on your own. Others would be like effects, life cycles, and performance. Like React gives you effects. You can hook into the effects, like if there is or a life cycle methods, like if it's mounted, you have to do some side effects. If it's unmounting, then you have to do something. You can do that, right? So that one thing maybe. And then the performance is something I think sort of like a controversial thing with the React. A lot of people think that React sort of screw up the performance of the app. It's sort of correct for the like a 20% of application, but 80% of application, when you need the very generic applications, I think React is a great tool. You it just knows like you have to declaratively tell like this is I have to create. It will handle everything. You don't have to manage the resources. You don't have to create it. You don't have to update it. You don't have to understand like how to free up those resources. You don't have to, when you say on click on the div, you don't have to go and remove the event listener, which is big thing when you use building the big application, where you have to understand like how memory consumption is happening, and you don't want to get into this memory leaks and all. So I think React is doing that really great, so why not use that? So it will be cool if we can use these same things like being reactivity, JSX, and the ecosystem outside of the UI, outside of the DOM, right? So I think that's where it comes in, like how to build your own React renderer. So we'll create a React renderer, very basic React renderer. I'll show the process, like how it's will be like 100 lines of code, and that's it. So I'll just showcase. So what we're going to build is, so basically we're going to build a React renderer for the library called ZDog. So ZDog is a uh, that's what I was explaining, right? You'll have like a declarative API where you are like you can use the reactivity, then you can use the JSX to uh, declare how your uh, view should look. Hmm. So there is a more to the web application than the DOMs. So you have like a WebGL APIs, you have the canvas, you have the 2D canvas, or you have the SVG based renderers, right? So those are the things I think where these things comes in. It is not like you'll be doing this in your day-to-day life. It is not like a, but there it's more like a solution when you are working in a web application where you are not just specifically working with the DOM. So that's where the problem starts, like if you're using like a UI or React for the UI, and then you will have like underlying canvas for let's say you are building a 3D editor, and then you have like a UI elements on the React, but then you also, then you have like something like a canvas. You can render the canvas on the, but everything else, that whole 3D rendering is happening inside the canvas. It is not a DOM, right? So you can't do that. So what you will have to do is like you will just create some side effect, and in that side effects you will keep doing it, and then you'll have like a 50 use effects, and you'll be not able to trace back to where the things are screwing up, if they screw up. And most probably they will screw up as the project get large, because the more the use effect in use React, you lose the control basically, right? So that's the issue. In those cases I think it's useful. Yeah. So basically this is the ZDog library. I think it is released like a 5 years back. It is like a 2D canvas based pseudo 3D engine. You can create this sort of like a illustrations or icons using this library on a JavaScript. It has like a two modes. You can either use the SVG or you can use the canvas, whatever. So we're going to use for it canvas right now, though you can just use the SVG. So we'll understand like what is the API. So to okay, I'll just getting started. So basically what you'll need is the, so to build a React renderer, one will have to understand like how to set up the React renderer, custom React renderer, and those configs. But even before that, we'll also have to understand like API for like for what we are creating the renderer. So I'm making sure like everybody gets familiar with the API. It's a very basic. The reason I chose it, like it's a very basic API. It has like a 4 to 5 methods, and that's it. So in ZDoc everything, so basically it has this root element called illustration. Illustration is more like a scene. Within a scene you can add some uh, graphics, but you'll need the scene that will be like a root of your uh, graphics. So it starts with the creating the illustration, and within the illustration then you can create the different shape. Here they created the ellipse, and you have the ellipse. Currently it's just drawing the 2D, and then you will have to update the render graphics because it has to draw on this canvas, right? To animate it, you just call the you just update its props, and then after updating the prop, you will have to call the update render graphics. It will again render it on the screen, and if you do it in the request animation frame, it will do like a 60 frame per second or more than that. It depends on the refresh rate, and you'll see like a animation. Correct. uh, this is like one of the basic example. Again, like it has some primitive shapes like a ellipse shapes. Shapes is like a base level uh, API to generate custom shapes. But apart from that, on top of that, you have ellipse, rect, all sort of those things, or triangle, or those things, right? And if you go to the APIs, if you go to the shapes, they'll have like all the shapes. But yeah, we don't need that right now. And all these, like, you just can change the props, like what props it accepts and what those things does. It is that, but we don't need that right now, because yeah. Then it has like this I add child API. So if you want to create like a children of it, you can use the add child, or if you want to remove, you can use the remove child. If you want to remove that instance itself, then remove its method. And then there is a update graph and render graphics canvas. These are more like a low level APIs. We don't need them right now. So yeah, I think everyone is familiar with the now API. We can go to the, so there is a something called another package we will need is a React reconciler. Yeah. So this is the open source package from the React. It will, you can pass the host configs to this package, and it will create the renderer for you. Okay. So these are the two packages outside the React we are going to use today. So if I'll just, is it visible? Creator, yeah. Mm, 10 minutes. So we have like this basic application. If you go to the main JSX, you have like this React DOM. Within the React DOM, you have like something called create root. So you will create a root. You create the root of your React application. So in the React DOM, it is like a div element, and then you will render your React code within that, React components within that, right? We'll try to simulate the same API for our render. Let's I'll create. Okay, needs, we'll call it create root, or it will take the canvas element, and it will return an object, and it will render, and you will have like a, within the render you will have like something, your React component, right? Apart from that, yeah, so I'll copy paste the this shell structure. This is basically like all the methods come with the React reconciler that you'll need. Not all actually, but all the method it gives. We'll see what are those. So uh, so when you, okay, cool. Right now what I do is, let's say if I will need the root, which is the canvas. You can again use the React itself to render, create the canvas element within the application. But for right now we'll just create, so you'll have like a structure something like a React DOM, and within that you'll have like a DOM elements, and then you'll have a canvas. Within that canvas you'll have another React application that will be your React ZDoc, that will understand that. So those will be like a separate tree but connected through the canvas element itself. But right now we'll create a canvas in the HTML itself. We'll give the ID of React ZDoc. It will give me like a create root. It will need the canvas element. Document development. And then it will give you like a render. Within that you can render something. Right now it's a fragment. So if you go to the ZDoc API, what you'll see is to create any element, it has some standard APIs. It is like a ZDoc.anchor or ZDoc.rect or any shape that you want to, right? So if you want to try to like achieve something, do we have something basic? Let's say this one. Okay, I want the tree structure actually. Mm, so we'll see the imperative API itself here. So you create the rect, right? Within that they have created the shape, and they added that shape to the rectangle. So like this is a tree structure, like you have the illustration at the top, and then you have the rect, and within that rect you have the one more node called shape, and then you copy the same, then you have like a two childs, within that you have another child, correct? So you have like some very basic tree structure. We can use this one, right? To create so if I'm creating this one, so what JSX API for this should look for us is like something like, I'll create a rect. If I create a rect, it should create a rectangular in ZTalk, right? And then within that it will have a shape, right? And it will have some props, right? You can say const you have this, and then you spread those over, and same for the shape. Spots, and you want to render it has to render this, or we can just create to sec for now. Up to so basically what we're trying to do right now is like just create a very similar to the API to the React DOM, so you can connect the dots like how the things are happening within the React DOM itself, and then how we can like just port the same thing within the another application, right? So whatever the shape they have created, like this is like a whole JSX will look like for it, right? It will have the illustration will be like a root that will create within the render method inside our application, but the user will just create the reactor shapes. It will just give the shapes, and then will do everything else. So if we go to the, it has the canvas element, and since we get the canvas element, it's to create the whole root for the illustration. You will have to get this illustration which takes the, which can take the canvas element, right? And yeah, it has the will create the container. And if the container is not there, React reconciler gives the like within the React reconciler there is a two methods called the create container and update the container. First time you will have to create the container, and every time next your whole application updates, it will give the update. So we'll have to check like if the container exists. We won't create it, we'll just update it, but if it doesn't, we'll create the new container from the scratch. So reconciler which we created here can create the container. So if you look at it, it takes the container info. So our container will be the elo variable, which is the illustration, correct? And then you'll have like a root tag or like a which element. And so for the hydration, we don't need the hydration, so we can set it to the null right now. And again, strict mode, we can set it to the, okay, cool. Once it is created, we'll just do reconcile dot container. So within the update container, you'll have like a what React element. So it's a React component that we'll be getting. That you'll have to pass, and within that like element, and then the container that you have created, which is and it will be null for now, and then you'll have a callback which will just lets you know like when the thing has done, when it is updated, right? And then on that, like since we have to update some illustration, we'll just do like update render graph. Should try to see if it works right now. Zdog is not defined. We'll have to import the Zdog. Consider component info root tag. Has the how much time? Finished. I'll just, yeah, actually I have, that's what I'll do. Basically what I'm trying to show here is like so upper one is like a imperative, I have built using the imperative and I try to reproduce application within the React itself. So if you go, this is basically happening in the React DOM, but then you are rendering this graphics as a side effect. So API for that will look like something like this. uh, so you'll get a canvas within the React, and after it is rendered in the use effect, you'll do everything as a side effect. So it is not related to the React, it will just happen outside of it. Correct. So when you see this use effect, so everything that you have to render within that canvas, you will have to do it using the use effect or some sort of side effects, whatever you have to do, right? Or you will have to take the instance of the canvas, export that, and then use that outside of the React application, which is then the communication gets very hard to make. But if you go to the React ZDoc, I created the app 2. In the app 2, you'll see I have made the I component, and then within the I component, you'll see that I have something like I have mentioned the reactor shape, or I have declared the JSX, and from this JSX, it is rendering these shapes, right? So how it does is basically you have this all these reconciler methods. So reconciler will give you something like a create instance method. So every time it has to create some node, it will call this method, it will trigger this method, and within that method you will get access to what kind of like a JSX element it is, like a type, what are all props it has, so props, and then it will also give the reference to the root container if you need that, right? So if you have a type, since we have the rect, we can convert it to the Pascal's case and then use the ZDoc, and it will at the runtime evaluate this and will create those instances and then apply the props to it, and then we'll return the instance. The reason we have to return the instance is basically is like React doesn't understand like what it is creating, and it needs the these references in the another methods where you are adding or deleting or adding appending the childs, right? uh, you can create the text nodes, but since it's a graphics, it doesn't support the text. We can throw the error if users tries to create the text. It gives like for the appending the child, it has like a three different methods. Append the child to the container, so the root elements which are creating, which are going to append it at the container level to the root element. At that time it will create it will trigger this method, and you can add child as a way you want, right? and same for the append child, it will be just like a parent and child. And same for the append the initial child, where the layout really matters. In this case, layout doesn't really matter. If it's initial, it does like a same thing. And so for all of this, the API is the same. All you are doing is add child. After that, you are doing like something like a remove child from the container, and the remove child again from the container. If you have removed, if you have some different API, you can create do those things here. But if you have like a separate APIs for the just generic parent and child, then you can use it. But for the ZDoc, it is same, so we can use the same API, right? Again, there is another method called the insert container before and insert before. So again, where the layout really matters, HTML, where the layout really matters, where do you are putting. So if you're putting the li first and the last, it should uh, if you're adding the new li at the top of the list, then it should create at top, not at the last, at the end of the list, right? So at that time you can use these methods, but here we don't need this. uh, then there is a prepared and commit updates. So after doing all the reconciliation, it does like a diffing and all, and it gives you like a what are the new changes, what are the new props, and it also gives you access to the old props. So if you want to do extra level of diffing or extra level of checks to go through the next stage, then you can do it here. All we are doing here is like we are just removing the reserve props like key, children's, or self source, all these props, and then we are passing that, we are returning that payload, and whatever you will return here, that will go to the commit update. At that time, you will apply those changes to the your view. Those will be rendered on the screen. It is just preparing. You will just see like what you have to update, and you will pass that payload, and it will go to the commit update. In the commit update, you are just applying the each uh, prop to the instance of that particular ZDoc element, right? After that, it has like some other finalize initial child or something like that. Another one which is useful here is a get public instance. So every time you do like something like a ref element on the ref is equal to some use ref, and you get the access to the imperative element of that uh, JSX. This is where it gets like if you don't return anything here in the ZDoc, in our renderer, you want, even if you do the ref, you will get not anything. So you can basically create your own structure to give the access to the your API, correct? So here we'll just return the instance. Apart from that, like to delete something, you will do the like something like instance.remove, and it should work. And so what you're doing is like just creating some sort of like a plugin where you just plugging in your APIs, and it is evaluating that JSX at runtime and creating those particular elements at a runtime. So you get this so you get this like sort of like a imperative API. So you have like a I component, within that you're rendering like a rect, and within that then you can reuse those components. So you're getting all of those things, and then you can use the state within it. So it is just so it is a reactive by default. Otherwise, if you're doing it imperatively as a side effect, what you'll have to manage like okay, so if this prop has changed or this state has changed, then I'll write the use effect particularly for that, and then again you'll have to maintain the syncing between the rendering and the state. Even though the React is giving you the reactivity, you can't really use it. As opposed to here, you'll just get that out of the box, right? So yeah, that's it from us.